So for number 19, if it is determined experimentally that a load of 30 kg applied to an extension coil spring will provide a deflection of 180 millimeters, what load will deflect the same spring by 50 millimeters? So first, we write the given. Okay, so we are given for mass 1, we have 30 kilograms. And then we also have a deflection 1, which is equivalent to 180 millimeters. So, and then we also have deflection 2, which is equivalent to 50 millimeters. So now we are tasked to find the deflection, or I mean the load, mass 2. So what load will deflect the spring by 50 millimeters? So for our solution, so first we should know that the deflection formula is equivalent to 8fnc cube over the modulus of elasticity, and then multiplied to d. This is g is the modulus of rigidity. And now we should take note that we only need the force and the deflection because only the same spring will be used. So the materials of the spring should be constant, or it should be the same. Therefore, we need to note that the modulus of rigidity, the wire diameter, the number of coil, and the spring index should all be constant, and we can isolate all of them at the other side. So let's try that. G D over 8n c cube equals to so this is f1 over then deflection 1, and we can also equate this to f2 over the deflection 2, since the same material or same spring will be used to determine what mass or what load should be applied to have the deflection 2. So we can now try this relationship. I mean, we can now change force to mass, because we are only interested in knowing the load of what load should be applied. So let's change this one. M1 over deflection 1 equals to M2 over deflection 2. So we can isolate mass 2, which is equivalent to deflection 2 times mass 1 over deflection 1. So substituting the values, we have 50 millimeters times mass 1, which is 30 kilograms, over deflection 1, which is 180 millimeters. So this will cancel, and now we can get mass 2, which is equivalent to 8.33 kilograms. So this is our final answer.